In this video, you will understand what brittle fracture is, and exactly when you must perform a fitness for service assessment to keep your equipment safe and reliable.
S curve. Okay. So this is a typical curve for carbon and low elastic. Okay. It's not applicable for all the materials, right? Stainless steel will not behave like this. So this is a typical curve for carbon and low elastic. And brittle fracture is more prone in these materials. Okay. SS is not prone to brittle fracture. So this curve indicates if you are on the right hand side of the transition temperature, your ductility will be higher. If you are on the left hand side, you are having very low ductility. Okay. So energy absorbed while failing will be much lesser if it is ductile. Okay. If it's brittle. Okay. So with that, okay, now if any equipment has been designed new, definitely we perform brittle fracture. But if the vessel is very, very old, the code might not have that section, So while assessing, we have to see that first point, whether the initial code with which it was designed was having this assessment criteria at that time or not, whether it was designed considering that brittle fracture or not. Okay. So when we are assessing that brittle fracture, okay, so what we are trying to assess is to avoid the catastrophic failures which may happen because of the brittle nature of that material, right? And we want to screen to not to arrest. We cannot arrest brittle fracture, okay? But what we can do is to screen whether there is a possibility of that happening of the brittle fracture, okay? So we are not going to arrest. We are not going to do something which may arrest. There are few things which you can do to improve that. Okay, we also saw that in the video. You can do few things which will be able to prevent these kind of things a little bit. Okay, but in vessel we are not going to bolt two plates, right? Like ship. So, but there are other ways. We'll talk about that. You can do small things to improve that. Okay. But the main purpose of doing this assessment is to check whether there is a possibility of brittle fracture. Okay. Now, when we have to perform brittle fracture or brittle fracture assessment, first point, like we discussed, construction code did not have that prevention earlier. So that time we'll have to do. If there is a change of MAWP, pressure has been increased, that will increase the stresses in the part. Okay. So you may have to assess the brittle fracture. PWHT status was changed. How that can be changed? If the vessel was built, PWHT was done, but later on during operation, during shutdown, you have some repair work on that vessel. So now if you have welded, it should go or should see PWHT, right? But that was not done. So now PWHT status is changed. So you have to assess whether we can run that equipment as it is, or we have to do some PWHT. Any change in operating condition. Pressure increase definitely will increase stresses, but lowering the temperature is directly influencing or being problematic for your brittleness of the material. Okay. So changing an operating parameter will contribute a lot. Now, if the tensile stresses are greater or equal to 55 MPa, so if the equipment is under high stress at even room temperature, okay, and one of the following exists, that also is the probability of brittle fracture. So better to do the assessment. Okay.